Hey, welcome to the lesson on how the greenhouse effect works. My name is Sandy, and thank you for joining me. In this lesson, we're going to slow down and focus on one of the most important ideas in climate science, and that's the greenhouse effect. You've probably heard the phrase before, but sometimes it gets explained in a way that makes it sound like the greenhouse effect itself is bad, and that's not quite right. So, the greenhouse effect is actually necessary for life on Earth. Without it, Earth would be much colder. The problem is not that the greenhouse effect exists. The problem is that human activities are adding extra greenhouse gases to the atmosphere, and that strengthens the greenhouse effect. And when we talk about the greenhouse gases, we're mainly talking about water vapor, carbon dioxide, methane, nitrous oxide, and the ozone. And there are some others, but those are the main ones that we're talking about. So, our goal in this lesson is to understand three main things. First, it's what the greenhouse effect is. Second, why it's necessary for life. And then third, how extra greenhouse gases make Earth warm more than it normally would. And our essential question for this lesson is, how can the atmosphere warm Earth without acting like a solid lid? So that question really matters because the atmosphere is not a blanket in the simple sense, and it's not a glass ceiling like a greenhouse. Energy is still moving in and out, so we need to understand the flow of energy, and we got to start with the big picture. So Earth warms when it absorbs energy from the sun, then it cools when it sends energy back out towards space. And so climate is partly about balance. Energy comes in, energy goes out. And when those are balanced over time, Earth's temperature stays relatively stable. And then we have these greenhouse gases: water vapor, carbon dioxide is CO2, methane is CH4, nitrous oxide N2O, and ozone O3. And then there are other fluorinated gases. So the sun sends energy to Earth in shortwave, and then some of that sunlight gets reflected back to space by clouds, ice, snow, just bright surfaces. But a lot of it reaches Earth's surface and gets absorbed by land, water, and other surfaces. And then once the Earth warms up, Earth sends energy back upward as infrared energy. And then we often think of that as our heat. So the basic sequence is energy comes in, some of it automatically reflects away. Some of it gets absorbed onto the Earth's surface. The surface begins to warm. Then the warm surface gives off infrared back out into the atmosphere and into space. And then that energy flow is the foundation for understanding the greenhouse effect. And so let's break this down into step by step. So, step one is sunlight moves through the Earth's atmosphere. So the atmosphere lets most of this incoming sunlight just go ahead and pass through. That's why the surface of the Earth can warm in the first place. Now, not every surface responds in the same way, right? So we have bright surfaces like snow, ice, and some clouds will reflect more sunlight. That means it'll bounce back. And then we have darker surfaces like oceans, pavement, or dirt or a soil, which will absorb or let in more of that energy. And when we think about it in our own living type of spaces, this is one reason surface types matter in climate. So a playground with a darker kind of pavement will get much hotter than a pavement with grassy or shaded areas. Also, when we think of an ocean, it's going to absorb energy very differently than an ice sheet, which will reflect that energy. So we can see that climate is connected to Earth's surfaces as well, and not just our atmosphere or the air. So the main point here is pretty simple. The sun is the main energy source, and it's going to drive Earth's climate. And much of that energy can pass through the atmosphere and warm the surface of Earth. Step two, right? The sun's rays come in shortwave, but once the Earth's surface warms, it gives that energy back as infrared energy. And anything with a temperature gives off infrared radiation. So that includes the ground, it includes the ocean, it includes buildings, it includes roads, and even us. So anything that gives off a temperature actually is giving off infrared radiation. And then this is where the greenhouse effect really starts to matter, because the sunlight, like I said, comes in as shortwave energy, but the Earth sends it back mostly as infrared energy. And the greenhouse gases are especially good at absorbing some of that outgoing infrared energy. So think of it this way: the sun's energy gets in pretty easily. Earth's surface warms up, and then the Earth tries to release some of that back out as infrared heat. And so then the question becomes, what happens to all of that outgoing heat? And this is where the greenhouse gases actually come in. So our step three is the greenhouse gases absorbing and re-emitting or redirecting some of that infrared energy. And this is the part where students often misunderstand. So you have to be careful when you're teaching it to students. And it's that greenhouse gases don't stop all the heat from escaping from Earth. The greenhouse gases, remember we said the main ones are going to be CO2, carbon dioxide, methane, CH4, water vapor, H2O, and nitrous oxide, N2O. And the greenhouse gases, they're not going to stop this infrared energy from coming back. It's going to redirect it or absorb it. So absorbing would mean it just goes and it's just going to sit in that molecule. Redirecting just means it's going to maybe move them sideways. Or redirecting, some of that infrared is still going to escape out. So Earth is still sending energy back towards space, and then some of that energy is still going to escape, but our greenhouse gases are going to absorb some of that infrared energy and then send it in different directions. Some's going to go upward into space, some's going to go sideways, some's going to go back down to the Earth's surface. So that just means that the heat escape that we would normally have is going to move more slowly. It's just going to be slower. And I really like the phrase in here that they have in this slide, came from a presentation in Canva. But that just, I like it because it's pretty accurate. And I hear a lot of times teachers will tell younger students in particular how the greenhouse gases act as like a blanket over top of the atmosphere, trapping in our heat. And while, it's a good starting point because it's a reference point that younger students can understand, but saying something more like the greenhouse gases act like a traffic slowdown for heat is a good way to put it, because it kind of clogs up this infrared radiation from leaving out of the atmosphere. So they don't block it completely, like block the road, but they slow the movement of the heat leaving Earth. And that's pretty important. And again, we're talking about carbon dioxide, methane, water vapor, nitrous oxide. So the key idea is that greenhouse gases make it harder for Earth to actually lose its heat quickly. And that is what's warming the lower atmosphere and the surface of the Earth. And when we talk about these greenhouse gases, we do need to separate the two ideas of the greenhouse effect. We do have the natural greenhouse effect, which is just a normal process, just like we have the cycles of water vapor or of the water cycle, and the enhanced greenhouse effect. And the natural greenhouse effect is helpful. It's what keeps it enough heat near our surface to make the planet habitable. And without it, Earth would be far too cold for life to exist as we know it. Right? We already know, or you may not know, Earth is in what we call the Goldilocks zone because it's the right distance from the sun for liquid water to exist. And the natural greenhouse effect helps keep Earth's surface warm enough for that water and life to exist, where the enhanced greenhouse effect is different. The enhanced greenhouse effect happens when there's extra greenhouse gases building up in the atmosphere. And then those extra gases absorb and re-emit or redirect more of that outgoing infrared energy that the earth is, trying to release, which means we have more heat directed downward and the heat is escaping more slowly. So this is why we don't want to teach students that the greenhouse effect is bad, because that's a little too simple and it kind of creates that confusion when they hear climate change and then they hear greenhouse gases. So the more accurate teaching point would be to say the natural greenhouse effect supports life, and then the enhanced greenhouse effect or too much greenhouse gases is the problem because it strengthens the warming of Earth. Another way to help students understand it is the teaching point. You can kind of use Goldilocks as a reference, is what I like to use. And it's that the natural greenhouse effect part is what makes Earth just right. And then the enhanced greenhouse effect is what happens when there's extra or too much of the greenhouse gases, which makes the system warmer than just right. And then that distinction of just right and too much is what actually matters. And so let's pause and kind of put a pin in it and put the whole process together again. So we're going to start here at the beginning and just work our way across. So first, we have the sunlight that enters the Earth's atmosphere, and it's going to come in a short wave. And then second, some of that energy is going to reach the surface, right? It's going to penetrate and it's going to go into the surface of Earth. And then third, it's going to the land in the ocean is going to absorb some of that energy, and ice and other reflective surfaces are going to bounce it back up into the atmosphere. And then fourth, the warming surface of the earth is going to send infrared energy back up. And then fifth, the greenhouse gases are going to absorb and then remit some of that infrared energy. And then finally, when there are extra greenhouse gases, the effect gets stronger and heat escapes more slowly overall. So here's the one sentence takeaway from all of that. Climate change is not the existence of the greenhouse effect. Climate change is connected to the strengthening of the greenhouse effect. So let's kind of think it through with a few quick checks now, kind of see how much of that has absorbed into your brain. And we're going to try to answer 3 questions to check for just some general understanding. Just 3 quick questions. I'll let you just think through. No high pressure stakes, but it's necessary for you to understand the basic understandings of the greenhouse effect. So let's take a look at the first one. Why does Earth keep warming even though it's constantly sending infrared energy upward? I'll give you about 10 seconds think time. Of course, if you were doing this in class, you would want to give your students however much think time you would need based on your grade level. So why does Earth keep warming even though it's constantly sending infrared energy upward? So if you had a response that included that some of that outgoing infrared energy is absorbed and re-emitted or redirected by greenhouse gases, in different directions, sideways or back down to the surface. You can even include, back into space. So heat does not escape as quickly. Right? And if it goes into space, that wouldn't really impact the heat down here on Earth. But if you just wanted to say the direction that the greenhouse gases cause that infrared heat to move, as long as you phrase it in that way. Let's go ahead and try number 2, quick check. What is the difference between the natural greenhouse effect and the enhanced greenhouse effect? 10-second think time. If your response said the natural greenhouse effect keeps Earth warm enough for life, and the enhanced greenhouse effect happens when extra greenhouse gases strengthen that warming. And you can have, of course, any kind of version of that, but as long as the main idea revolved around those 2 main points. Good job. Okay, and let's try our last one. It's going to be more of a fill in the blank. Finish this sentence. Greenhouse gases do not stop all heat from escaping. They, 10 seconds. Greenhouse gases do not stop all heat from escaping. They slow the outward flow of heat and redirect some energy back towards Earth. All right, if you can explain greenhouse gases in your own words, then you have the core idea. Now, if it still feels a little abstract, that's normal. Energy moving through the atmosphere is not something we can see directly, so analogies can usually help. But I want to say something important about analogies. Every analogy has its limits. You might hear people compare the greenhouse effect to a blanket, a car with the windows rolled up, or an actual greenhouse. Those comparisons can help students get started, but none of them are perfect. And of course, you want to tailor your explanation of greenhouse gases to the grade level that you're working with, but it's pivotal that you understand completely how the greenhouse effect is actually connected to climate change. And so the atmosphere is not a solid lid. Like, it doesn't just pop on. It's not a glass. It's not a blanket with no gaps. So when we use an analogy, we want to use it as a bridge, not like the full explanation. And then the real science is still this, that the sunlight comes in, the earth warms, earth gives off infrared energy, greenhouse gases absorb and re-emit some of that energy, extra greenhouse gases strengthen that effect. That's the core of what the greenhouse effect is. But, sometimes we have to hear it multiple ways. And in a classroom, always try to give different versions or variations of explaining the same kind of topic, because repetition does help. And so this diagram gives us another way to look at the same idea. Sunlight reaches the earth, some of that solar radiation gets reflected back into space, and then some of it's absorbed by Earth's surface. So this would be a good diagram to even have students use to diagram and demonstrate it in their own with the use of arrows. And then when the surface warms, it gives off infrared radiation. Some of that escapes and back into space. Some gets absorbed by greenhouse gases in the atmosphere. And then again, we're not saying that heat is trapped forever. That's not the best way to think about it. It's better to say that greenhouse gases slow the release of heat and send some of that energy back towards Earth's surface. And then that's why the Earth stays warmer when it would be without having greenhouse gases. And so for this diagram, just a natural greenhouse effect, natural levels, greenhouse gases help keep Earth's temperature in a range that supports life. They allow that incoming sunlight to reach the surface, right? See those arrows coming down there? And then they absorb some outgoing infrared energy. And that is not a problem by itself. In fact, it's one of the reasons Earth is livable. So when the students hear greenhouse effect, we don't want them to automatically think bad. The natural greenhouse effect is part of Earth's climate system. And the issue is what happens when we add too many of these greenhouse gases than the system had in it before. And then that enhanced greenhouse effect, again, we can see we have all of these multiple greenhouse gases here, and then we can see how things are just getting bounced around in a lot of different ways now. And it's getting trapped in that carbon dioxide, methane, nitrous oxide, and we have more outgoing radiation is absorbed and reemitted. So we just get a lot more that's coming, and that heat's redirected back downward more, and the atmosphere begins to warm, and human activities are increasing the concentration of these gases. Burning coal, oil, gas releases carbon dioxide. Agriculture and waste release methane. And we're going to cover this in our module 2 of some of the drivers of this increased greenhouse gases. So the enhanced greenhouse effect is not a totally different process. It's just the same basic thing, but stronger. And then that's the key idea you want to tell students. The natural greenhouse effect is necessary, where the enhanced greenhouse effect is strengthened by extra greenhouse gases and connected to our current warming. And then this diagram just repeats the same idea visually. Sunlight travels to Earth. Some energy is reflected. Some is absorbed. The surface warms, gives off infrared. But now that we have more greenhouse gases, that infrared radiation is absorbed and redirected. And sometimes this is where students will get stuck because they imagine that the greenhouse gases create the heat from nothing, but they don't. So they're like, oh, there's just the greenhouse gases are there, and that's what's making it hot. But that's not the true effect. Remember, the greenhouse gases kind of redirect and absorb some of the infrared radiation that the Earth is releasing. So the heat starts with energy from the sun, the surface absorbs that energy, then releases the infrared energy, and then the greenhouse gases just affect how quickly that energy leaves our system. So a good classroom question would be, are greenhouse gases adding heat by magic, or are they changing how energy moves through the system? And then having students be able to explain that. And then lastly, you can just use a diagram to explain it. That's another powerful way to explain the greenhouse gases. And then just being able to walk through what happens with the greenhouse effect. So I'm just going to let you take a minute and try to explain the greenhouse effect in your own words. And then use this sentence for a sentence starter if you need to. The greenhouse effect happens when, and then you can allow students to write down like a quick write for a minute, 2 minutes. It's your choice of how long and what your grade level is when you do this as a quick write. Okay. If you could explain that sentence starter in 2 sentences or more, then you're ready to move on to our next part. So thank you. I hope this helped give you a very strong understanding of what the greenhouse effect is and how it relates to the warming on the planet. All right. Thank you. And then move on to your next models. Bye.